Now, I was debating if I wanted to show you how to convert between degrees and radians or not. It is a very important thing to know, but at the same point, it can kind of make this next thing that we're going to do a little tricky. So our next example, we are going to find those trig functions, SOHCAHTOA, and also secant, cosecant, cotangent, of different angles when we're given our angle measure in radians. So that's what we're going to do here. Find the values for all 6 trig functions of 3 pi over 4 radians. Now, first of all, let's think what 3 pi over 4 radians is. And like I said, this is the fact that I showed you how to convert is kind of tricky. We don't want to convert this to degrees. Say that again. We do not want to convert 3 pi over 4 radians to degrees in order to find where that is on our coordinate plane. Keep it in 3 pi over 4 radians. So here's my coordinate plane. We're going to start here. And just like before, this angle measure is 0. 0 degrees, 0 radians, 0 everything. Now up here, we used to think of this as 90 degrees. How many radians is that? Well, let's come back to it. All the way around our circle is 2 pi radians, which means halfway around our circle is pi radians. So again, 180 degrees is pi. Halfway between that, halfway between 0 and pi, is pi over 2. So we have 0, we have half of a pi, we have a pi, then we have 1.5 pi, or 3 pi over 2. And then we have 2 pi's. Now, where's 3 pi over 4? Well, 3/4 is less than 1. You really can think of this as we are 3/4 of the way to pi. So here's a half of a pi, another quarter brings us here. So just like before, we figure out where our angle is, draw our line, draw our perpendicular to the x-axis, and then we need to think about, well, what kind of triangle do we have here? This is halfway in between, so this is a 45-degree angle. We have 45, 45, 90 triangle. So this is 1, 1, square root of 2. And since we went left on our x-axis, this is -1. Up on our y-axis, that's positive. And our hypotenuse is always going to be positive. Okay, so we have our triangle to work with. Now let's think of our 6 trig functions. We have sine. We always have the sine of an angle. So the sine of 3 pi over 4, we need to find the cosine of 3 pi over 4, the tangent of 3 pi over 4, and then think about what goes with each one, our reciprocal trig functions. Well, tangent and cotangent are easy. And then we have secant and cosecant. Like I said before, each one has a co. Sine and cosecant go together. Cosine and secant go together. And don't forget also SOHCAHTOA. That'll help us as we go through. So looking at my triangle here, let's start off with sine. And the sine of our angle is the opposite over the hypotenuse. 1 over the square root of 2. Rationalize our denominator. multiply by the square root of 2 over the square root of 2. It gives us the square root of 2 over 2 as our sine. Okay, now cosine is adjacent over hypotenuse. Adjacent's -1 over the hypotenuse. -1 over the square root of 2. We'll have the same thing up here except a negative. Multiply by square root of 2 over square root of 2. Zoom in so you can see that a little bit better. And it's negative square root of 2 over 2 for our cosine. Tangent's a little bit easier. Tangent's opposite over adjacent. So looking at my angle here, opposite is 1 over the adjacent is -1. 1 over -1. Okay, now we have our reciprocal functions. There we go. So cosecant and sine are reciprocals of each other. And sine is opposite over hypotenuse. So that means cosecant is hypotenuse over the opposite. Looking at my angle here, hypotenuse over the opposite is the square root of 2 over 1. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse over the adjacent. Hypotenuse over the adjacent, square root of 2 over -1. And then tangent and cotangent are reciprocals. Tangent is opposite over adjacent. So cotangent is adjacent over the opposite. Adjacent over opposite, -1 over 1. And those are 6 trig functions. So again, the same idea as before. Once we get our triangle drawn in, don't convert to degrees. Can't stress that enough. We'll leave it in radians. The more you can think in radians, the easier they will be, and the easier pre-calc and ultimately calculus will be for you. So again, don't convert to degrees, think radians.